Good afternoon, dear students. Today now we are going to see about the pressure volume isothermy of carbon dioxide. Andrews isothermy. Andrew given the clear data about the pressure, volume, temperature of gas and liquid state. Okay. The graph, first of all, we are going with the graph. And the graph plotted between the pressure and volume, if you take. Okay. So the graph at a temperature, given temperature, pressure and volume is called isotherm. Andrews isotherm of carbon dioxide, which we are going to explain now. See here, the volume of gas at A to B, if you see A to B, the volume of gas is getting decreases at certain point. After B to C, the sudden the decreases of volume, but the pressure is constant here. This area is condensation region. Condensation region, okay, where gas and liquid are coexist. 13 degrees Celsius for carbon dioxide, this is the 21 degrees Celsius here, 31.1 degrees Celsius. Okay. Now, the successive isotherm. See, after that reaching here, the gas is condensing towards the liquid. At the point C you find the gases. Gas is completely converted to liquid. Then there is no change in the volume. Even the pressure is rises. The successive isotherm, A dash to P dash like is slide. Then B dash to C dash, the area is reduced. See, B to C, the area, the same condensation region is reduced. At a temperature variation, here 13 degrees Celsius, here 21 degrees Celsius. After that, 31.1 degrees Celsius, at a certain point, the region, condensation region become a 0. At a point P, the condensation region 0, the temperature is 31.1 degrees Celsius. Here, the gas is completely become a liquid. Carbon dioxide become liquid at this temperature. There is the condensation area is 0. Then after this temperature there is no possibility. After this temperature there is no possibility to liquefy the gas. So this is a temperature, liquefaction temperature. This temperature is called a liquefaction temperature. Liquefaction temperature. Liquefaction temperature or a critical temperature. How we can define the critical temperature? At a temperature above which the gas cannot liquefy, that is called even at a high pressure, that is called a critical temperature. This is for carbon dioxide. PV diagram for this, PV isotherm for the carbon dioxide is given by Andrews. So once again I am repeating this, what I is explaining this from. When the condensation area is reduced for successive isotherms, at a certain point the area is become 0. Okay. That means here the carbon dioxide is completely become a liquid. Above this temperature, this is the liquefaction temperature of carbon dioxide, 31.1 degrees Celsius. Above this temperature, there is no chance of at any temperature the gas cannot be liquid, and even at a high pressure. Okay, so this is a point, critical point. This critical point is called a critical temperature. Now we can define the critical conditions. So let us say what is the critical temperature. Critical temperature, the temperature above which gas cannot be liquefied even at a high pressure. Even at a high pressure. Even at a high pressure. So that particular temperature is called a critical temperature, that is denoted by Tc. Then critical pressure. Critical pressure is nothing but the minimum pressure. The minimum pressure required by a 1 mole of gas. Minimum pressure required by 1 mole of gas at Tc, critical temperature. This is nothing but a critical pressure. This is nothing but a minimum pressure required to liquefy 1 mole of gas at a critical temperature. Then critical volume, Vc. This is the volume occupied by 1 mole of gas at Tc and Pc. Not Tc and Pc. The volume occupied by the 1 mole of gas at a critical temperature and critical pressure is called a critical volume. It's nothing but in an another graph. There is a graph. It goes like this. At a certain point, the point P, you are getting that suddenly after this point there is no chance to liquefy the gas. That is for carbon dioxide 31.1 degrees Celsius we have seen. This is point. This is called a critical temperature 31 point. At the time, what is the pressure of gas? If you see this side, there is a pressure will be there. That the pressure is Pc. At the point, the volume, if you see the Vc, here Vc. Okay, the volume of the gas occupied by the gas is called a critical volume. At the point, in a critical temperature place, there is a pressure will be there. That particular pressure is called a critical pressure, critical volume, critical temperature. So once again, I am defining this temperature above which gas cannot be liquefied even at high pressure is called a critical temperature. It is denoted by Tc. The minimum pressure required to liquefy the 1 mole of gas at a critical temperature. The conditions should be mentioned at a critical temperature. The minimum pressure required by 1 mole of gas to liquefy at a critical temperature is called a Pc. The volume of gas occupied by the 1 mole of gas at a critical temperature and critical pressure is called a critical volume. Okay, this is output of the Andrews isotherm. Okay, let us see about the derivation of Pc, Vc, Tc. Okay. Now we are going to see about the derivation of Tc, Vc, Pc. Derivation of Pc, Vc, Tc by using van der Waals equation. Van der Waals equation. Okay, let me write the van der Waals equation first. P plus A n square v square b minus nb, that is equal to n RT. Okay, this is van der Waals equation. For n mole of gas, for n equal to 1. For n equal to 1, if you substitute 1 here, then the equation will become P plus A by B square B minus B equal to RT. Now we elaborate this equation by multiplying these two. PV minus PV plus AB by B square minus AB by B square minus RT equal to 0. Let us write like this. Okay. Then is there any chances to cancellation? Here B square will be cancelled. That's all, nothing to be else. Then you can write the elaborated equation PB and then PB A by B squared. B squared will be cancelled, so A by B minus AB by B squared minus RT equal to 0. That is maybe we keep it as 1. Okay. Then multiply the equation 1 into B squared by P. This is the term we are applying. What I am going to do? The equation 1 is multiplied by B squared by B. So B squared by P into PB minus PB A by B minus AB by B squared minus RT is equal to 0. Then PBQ by P minus PB squared by P plus AB squared by B minus AB. See, here you are missing the P. You have to remember. AB B squared by B squared P minus RT B squared by P, that is equal to 0. There are any chances to cancel? P cancel. Here P also be cancelled. Here B squared cancel. That's all. Then the equation will become V3 minus PV squared plus AB by P minus AB by P minus RT B squared by P equal to 0. Okay. Now in terms of V power, if you write the equation, alter the equation will become V cube first, then V squared, 2 times V squared is there, so P plus RT by P net V squared we can write. Then if you write in terms of V plus A P by V minus PB by P, that's RT squared already we have get into is equal to 0. Okay, the equation may be 2. Second equation I am writing the top again for the continuation purpose. Equation 2, V3 minus P RT by P V square minus plus AB by P minus AB by P is equal to 0. Okay. So V cube, V square, V and constant equal to 0. This we can write. Okay. Let it be the equation number 2 or 3. 2, let it be here. Now at the critical condition. Now we are going to apply the critical condition. What is the critical condition? At the critical condition, B equal to BC, P equal to PC, T equal to TC. This is a critical condition. If we take at a critical condition, what will happen? So from this we can write B minus VC equal to 0. Let me write like this. Then cubic equation, if you write V minus VC cube equal to 0. So if you write, you know, A minus B whole cube formula, V cube minus 3 V squared VC plus 3 V VC squared minus VQ. That is equal to. Now this equation is 3. Equation is 3. Okay. Cubic equation I elaborated. Now what I am going to do? Comparing 2 and 3 with the coefficients. See, V3, V3 both are same, but in V squared there is a changes. In equation 3, V squared, 3 VC is there, coefficient of V squared. Whereas there minus PRT by P is there. Okay, this is a coefficient of V squares. So minus cancel. So let it rise 3 VC equal to P minus RT by P. This is equation 4. Let me keep. Then I am going to compare the coefficients of V. V from this equation 3 VC square is there. Okay, if you compare the VC square in equation 2, what for V? A by P. This is equation number 5. Let's get equation number 5 like this. Then remaining thing there and here, we find minus AP by P in the equation. This is comparing 2 and 3. Don't make confusion. 2 and 3 are comparing. Coefficients are 2 and 3 are comparing. Here VQ. Otherwise, write the same. Minus VQ equal to minus AB by P. Okay. Now minus cancel. Then VQ equal to AB by P. This is equation number 6. Okay. Now what I am going to do from the, having this, I am going to get a PC, VC, TC. So let me have here. So divide the equation 6 by equation 5. So what is equation 6 here? See, one thing I want to say, in all cases you have to put at a critical condition we say, so all T should be TC, P should be PC, TC, PC, PC, PC. Okay. Then if you apply what is the VQ? VQ equal to AB by PC. This is equation number 6 divided by equation number 5. What you have 3 VC square. See, here also VC we have to put VCU. 3 VC square, that is equal to, when you write equation number 5, what I say? Divided by A by P. So A above you are getting PC. Now it's clear what I am doing, dividing 6 by 5. So what is the chance to cancel? CQ VC squared VCQ, no? You strike this, VC will come, then PC cancel, A cancel, and finally you are getting that is VC equal to 3B. So we got equation number 7, one solution we got at last. VC value, critical volume 3B, we are getting this. Now you put a VC value into any of this equation. I am putting the 7 into 5. 7 in 5. 7 in 5. What is the fifth equation? First you write 3 VC squared equal to A by PC. This is equation number 5. If you apply VC value in this, 3B squared equal to A by PC. Okay. Now, totally 9B squared into 3 A by PC. 27B squared equal to A by PC. What is the record? PC is needed. So PC equal to A by 27B squared. Okay, now you got equation number 8. X. Then if you substitute these both value BC and PC in equation number 4, you may get a TC value. Only left over what is our motive? To calculate the TC, PC, derive the TC, VC, PC. Now we got both VC and PC. You apply this into the equation number 4, you can get that TC value. So let us apply the 7 and 8 in equation number 4. First of all, you write the equation number 4. 3VC equal to P minus RTC by PC. That's all. Now you apply the 7 and 8 in the VC value and PC value there. What is the VC? VC equal to 3B. 3 into 3B, that is equal to B minus PC RTC by PC A divided by 27 square, it will go up 27B square. Okay. Now what happens in 9B equal to B minus already outside minus because it's 2 plus plus RTC by PC. RTC into 27B squared, 27B squared divided by A. If the B comes here, 9B minus B, any cancellations possible you see, then RTC into 27B square by A. So 8B equal to RTC into 27B square by A. So now we want a TC, no? So alter like this, 8 AB divided by R into 27B square, that is equal to TC. So here we, so finally TC equal to 8A by 27RB. Finally you got that TC value. TC equal to 8A by 27RB. From this you can calculate the A value and B value. Here also say by using this data 4 and 5, yes, 7 and 8, you can calculate the van der Waals constant A and B. So you want van der Waals constant B, you apply this equation A, you want A in a VC equal to B, no? What is the equation number 5? 3VC squared equal to 3VC squared equal to A by TC. A is a van der Waals constant, you want van der Waals constant A equal to 3VC squared TC. This is A value. You want to know B value, B also van der Waals constant, VC equal to 3B, then B equal to VC by 3. So that's all about the derivation of PCVCDC by using van der Waals equation. See dear students, listen properly. Once again I am going to derive the derivation for you. Just orally, now I am explaining this. You just listen properly, then you can do it. This is just a max, like it is very often asked 5-mark question in 1947 itself. Listen properly. So what is our motive? We are going to derive the derivation for TCVCPC by using van der Waals equation. Van der Waals constant A and B. Okay, this is interconvertible. If you know TCVCPC, you can calculate A and B. If you know A and B, you can calculate the PCVCDC. There is a double purpose work. Okay, First of all, I am writing van der Waals equation. It's a complete form of the van der Waals equation. This is van der Waals equation for n number of modes. For n equal to 1, if you substitute n equal to 1, then the equation will become like this. After this elaborating this equation, you may get this here till more elaborated, and in the form of, if you elaborated form, RT is giving, you are getting this one. The equation 1 is multiplied by v squared by p. For a convenient purpose, in order to get a VCTC value, I am doing this. Why? We may ask the question. Why, sir, we need to, for our convenience, in order to get a solution to VC or PCTC, we need to this factor we need to add. So v squared by p, we are going to multiply the equation number 1. If you multiply and you simplify this, you may get a equation number 2 like this. Equation number 2 like this. Okay. Equation number 2 in the form of powers of v, I am writing. Okay. Once again, I am repeating the equation number 2 here in the board. It will be like this. Here there is a missing one. See, p plus RT by p, I have written minus. It's a big simple plus minus causes many. Okay, you have to go through. Once you write the equation, this is the way you do the mistake. Properly you are going writing, simply you are missing the plus or minus, the entire network will be collapsed. Okay, that's why you need to revise. After writing the test also, you have to go through whether you are missing or then I am going to apply the critical condition. What is the critical condition? That critical condition, the volume will be called as a VC, pressure will be called as a PC, temperature will be called as a TC. This is a critical condition. So as per V equal to VC means V minus VC equal to 0. The cubical equation, if we take V minus VC cube, there you can apply A minus B whole cube formula, you know very well. That is A minus B whole cube equal to A cube minus 3A squared B plus 3AB squared minus B cube. This is the formula. I am using this formula and elaborating into this elaboration. As a result, I am getting that cubical equation that V cube minus 3V squared VC plus 3V VC squared minus V cube equal to 0. That is, I am keeping as a equation number 3. Okay. Then what I am going to do is I am going to compare these two. 2 and 3 I am going to compare by using their coefficients. So V cube 1, so both are same. V cube in 2 also 1, in 3 also 1. So there is no. Okay, here after this formula, cubical equation elaborated form, this will be like this: V cube minus 3V squared VC plus 3V VC squared and a VC cube equal to 0. Okay. When you comparing this the coefficients of V, then VC no chances, 1 will come. Whereas for V squared, if we take there may be a chances to get a VC. By applying this, you are going to get a 3VC equal to B plus RTC by PC. This is the equation number 4. Then you are going to compare the V of the both 2 and 3. In 3 for V coefficient 3V squared, VC squared, whereas in there you may get a by PC. Okay, A by PC. Then you are going to equate it, then you are getting the VC cube equal to, finally you are getting this VC cube equal to AB by PC. Okay, this is equation number 6. Now what we are going to see now, I am going to divide 6 by 5. The equation 6 is divided by 5. Why? Because then only we can get a VC value. Applying a 6 equation and 5 dividing, you are getting that VC equal to 3B like this. After that, if you substitute any one, 5 or 4, the VC value in 5 or 4, you may get that PC value. After that, you are getting PC value. By using the PC and VC value, you substitute any one of the equation, most probably equation number 4, if we substitute PC and VC value, you may get a TC value. So finally we got a PC, TC, VC. This is our form, we got it. From the PC, TC, VC also we can get a and B. A and B are van der Waals constant. A and B are van der Waals constant. That van der Waals constant also we can get from the VC, PC. If you apply any one of this formula, you may get a equal to 3VC squared PC whereas B equal to VC by 3. This is the derivation. I hope that you may get clear with the derivation. Very, very important derivation that you need to recall. So I want to conclude this class now. So whatever we have seen today is we have seen only Andrew isotherm and PCVC-DC derivation. Andrew isotherm, what we have seen there, the critical temperature of the carbon dioxide may be calculated from the Andrews isotherm. Andrews isotherm is giving a clear data of the gas and liquid at temperature, pressure and volume. Okay. So what is the critical temperature? Critical temperature, above this temperature, the gas cannot be liquefied, even at high pressure. This is called a critical temperature. A temperature at which, above this temperature, the gas cannot be liquefied even at a high temperature. That is called a critical temperature. Then what is the critical pressure? PC. Critical pressure is nothing but 1 mole of any gas. It is a minimum amount of pressure required to liquefy the 1 mole of any gases. Okay. That is at particularly we need to mention at a critical temperature, not in all temperature. At a critical temperature, the minimum pressure required to liquefy the 1 mole of gas. That is called a critical pressure. Then, critical volume. Critical volume is the gas, the volume occupied with the gas at 1 mole of critical temperature and critical pressure. So, at a critical temperature and critical pressure, how much amount of gas is occupied, that is called a critical temperature. Okay, that's all. Then the PCVC-DC diagram that we have seen. That's all about this lesson. So, okay, dear students, if you write twice or thrice, you may get very easy. It is very not difficult by seeming it's larger one, but it is not that much difficult. It is very easy, but you have to write and practice twice or thrice, then it will be easy. Very, very important 5 mark. And the data, the formulas you can use it for the neat problems and book back 1 words and everything. So be practice. Today itself you go and write, take your rough note and write and practice twice or thrice. You may get it clear. Okay. Thank you.